All right, so in the last video, I showed you how for loops work, and that was really cool, but really all we were doing is printing stuff out to the screen. What I want to do now is take just a second, kind of as an added bonus, and show you something pretty cool and pretty practical that you can do with for loops. So I'm doing this completely off the top of my head with no notes. I'm going to right-click, make a new blueprint, make an actor, and we're going to call this procedural wall. We're going to make a procedural wall system, and it's going to be amazing, and you're going to be really happy about it. So let's see, here we are in our components list. The first thing I'm going to do is add a scene component. This is, honestly, this is for the most part just habit for me, and we'll call that root. Now, over in the content browser, I have the starter content, so I'm going to go under architecture, and I'm going to grab this pillar here. So it's a little 50 by 500 pillar, and I'll drag that into my component list. And we'll call this base wall. And what we'll do is we'll just copy this over and over again in order to make our wall actually happen. So there we go. That should be all we need. Let's go ahead and jump over to the graph. And I'm going to show you more things than just loops. So we're going to do something that's kind of sort of fancy. We're going to create a new variable, and we're going to set its type over to a vector, and we'll call this endpoint. And we're going to set it to be editable, and we're going to show its 3D widget. And let's give it a tooltip. We'll say, this is the end of the wall, with an exclamation point, because that makes tooltip superior. Okay, so if I drag this out of the way, and let's go over to our blueprints list, or our blueprints folder, excuse me, we can bring in procedural wall, and it has that little endpoint variable, which we can click on, and we can move. So that's literally the value for that endpoint right there. Okay, cool. Now we need to make that do something. What I want to do is drive everything inside the construction script. That way we can move that endpoint around and make our wall get bigger and smaller right there live in the editor. Now the first thing I'm going to do is bring in my endpoint. We'll get a getter because I want to pull some information from it. And we're going to make sure that it is not equal to 0. So I'm just going to hit the exclamation point and grab a not equal node. And if it's not equal to 0, let's fire off a branch. And we can plug that into the construction script. And really all we're doing here is we're saying, if we are not equal to 0, then we're going to do stuff. If the endpoint is equal to 0, then it hasn't moved, and we don't really need to do anything. So it's kind of a check and balance to make sure we're not doing anything we don't necessarily have to. Also, I'm going to take the endpoint, and we're going to drag a wire out from it here, and we will multiply it by another vector. And I'm going to multiply it by 1 for x, and 1 for y, and 0 for z, because I don't really want the vertical side of it to even be calculated. I don't care about the vertical elevation for that little endpoint. So again, we're going to leave that plugged into the first entry for not equal to, and there we go. Okay, so now next thing, if our branch is true, then our little endpoint has been moved somehow because it is no longer sitting at relative 0, 0, 0. So now we want to run a loop. And this will just be a regular for loop. Now we're not going to worry about what the loop does yet. We're going to worry about how we figure out the loop. Now, as a reminder, my little pillar that I used, it has dimensions of 50 by 500. So we know that it's 50 in width and 50 in depth, and then it's 500 tall. So let's use that to our advantage. What we're going to do is grab the endpoint. So let's get another copy of that. I'm just going to hit Control-C, Control-V. It'll just keep wires from going everywhere. And I'm going to get the vector length. So there's a node that will do that, and that is just going to return a float value that represents the length of this vector, which is perfect. That is exactly what we need. We are then going to divide this by 50, which is what we know is our dimension for the pillars. Now, if that needed to be a variable, like if that had to be in flux, you could make that a variable and you could set that to be like the bounds of another mesh or something. We're going to keep this simple. We know our pillar is 50, so we're just going to divide by 50. Then we need to round this down, and the easiest way to do that, well, we're kind of just going to truncate it. So let's just run a floor on it. And that will output an integer. So if we had a value that was like 3.729, we're just going to get 3. And that can become our last index. We'll take our first index and just set that to 1. All right, so that's looking pretty good so far. Now we just need to figure out what we're going to do to create our wall. Well, we need to start making static meshes. So let's see, do we have our little pillar over here selected? It looks like we do. So let's right-click, and we will add static mesh. And you'll see there's add pillar 50 by 500 as static mesh component. Boom, perfect. Now we're going to do a couple of fancy things here. We're going to connect that to the loop body, because each time the loop runs, we want it to create another one of these. And we're going to set it to be manually attached. That means we need to, oh, okay, well, I guess I should step back. This is being added as a static mesh component, literally a part of this blueprint, another component. We're going to set it to manual attachment, which means we must manually parent it to something else in our blueprint components. So let's go ahead and do that next. So here is the component that just got created. So we'll say attach, and there's an attach to node, so that's what we want. The in parent is going to be the base wall. That is that first little wall that we created that's already there. The attach type, it almost doesn't matter, but I'm going to set it to keep world position anyway. Now the last thing we need to do is move this into place. So we've created it, we've parented it to the base wall, now we need to move it into its appropriate position. Now that should be fairly easy because we know that it is 50 units wide. Now we can take that 50 units and we can multiply it by our current index of the loop, because the first time the loop runs, the index is going to be 1. The next time it runs, it's going to be 2 and 3 and 4 and so on and so forth. So let's just start by multiplying integer by float, and we're going to multiply this by 50. The reason I chose a float is that that's automatically going to convert my final value to a float. That's super useful for me because I'm going to use this and make a vector. And we'll use the x value there. Then we're going to take the result of this vector and use it. Actually, let's just take our return value here off of our add static mesh. And we will say set relative location. We'll plug that in. That'll be the last thing in our chain. And this can be the new location. Now, this should already do something. We should probably go ahead and test it. You see, it's fairly simple so far. Hasn't been too hard to put together. Let's compile, drag window out of, actually, you know what? Let's put this up here on the tab. That way I can just jump between the two. That'll be nice and easy. And it's already doing something. Let's take our endpoint, and as I drag it out, check that out. We're getting more and more wall segments, depending on how far away we move the endpoint, which is cool, but it would be nicer if the wall was actually rotated to snap to the endpoint. So let's fix that next. So jump to back to the procedural wall. And we could comment all of this. We could say all this, and then hit C, and creates new wall segment based on distance of endpoint. Now, once the loop is completed, by the way, if you see an error on your loop, always hit compile, because it may or may not be a real error. So we'll go ahead, and when we're completed, the last thing we want to do after we've finished creating and parenting and doing all that fun stuff is then we'll handle our rotation. So what we're going to do is rotate the base wall. So let's get that, and we will, actually let's drag a wire off of that, and we'll say set world rotation, like so, and we'll just plug that in. Now, what are we going to set it to? That's the real question. Well, we need to figure out the rotation that is represented from the start point of the actor to the end point. That way, like, what would we have to rotate to if the endpoint was moving around like so? How would we make that happen? Well, the good news is that's pretty easy to do. We just need a little bit of vector math. We're going to start with the actor location. So we'll say get actor location. And then we need the endpoint. And from the actor location, we can say find look at rotation. So you can literally feed that a start point and an end point. It's kind of like saying stand at the start point and look toward the target, and then feed back the rotation required to look at that. Now for the target, we're going to take the actor location and we're going to add that to the endpoint. like so, and it'll give us the rotation that we need. Then we're actually going to break that. And all we're going to use is yaw. We don't want pitch and roll. So I'm going to take yaw, and now we're going to make a rotator. So in essence, that's just nullifying pitch and roll. And we'll plug that into our new rotation, and let's compile, and let's see what we get. Oh, it looks like it's already working. So now, if I take the endpoint, I can just move it around, and I get a little auto wall that just fits perfectly into any given location. I can take the original point, and I can use that to position the wall, like so. So we can just slap that right over here. We can take the endpoint, and let's just kind of cordon off this section. We don't want anybody coming over there. Cool. And once that's ready, we can hit play, and oh, check it out. We have a wall, and it looks just like a regular wall. Boom. Oh, can't move through it. It's pretty awesome. And you see, there's a couple little shadowing things with this approach. Like as you get distant, you can kind of see the gaps in the shadows, but you know, it shows how you could go about doing this. Honestly, if I was creating a setup like this, I'd do it for like a picket fence or something like a railway. I wouldn't necessarily do it with a solid wall like this, but it is pretty cool. Because for a solid wall, you could just scale the object, right? And that would work just fine. But this is a nice way to kind of go about proving the point. So I guess one other thing we could do, just because that, yeah, okay, I want to show one more thing. Let me jump back into the blueprint. You can close the video now if you really want to, if you feel like you've learned everything you need to learn. Let's go back into components, and I'm going to swap out the base wall with another mesh. Let's do the one that has the doors in it. If we go under, there we go. So wall door, 400 by 300. Let's do 400 by 400. I like the tall ones better. So we'll do that, and then let's go back over to our graph, and that is also adding in that guy. So static mesh. Oh, well, let me go. I'll go ahead and make sure I select that one. So let's jump over to architecture and 400 by 400. Make sure we have that selected, and then over in our blueprint, we can right-click and say add static mesh. Boom. And I'm just going to replace this guy. We're going to say you go there, you go there, you go there, and you go there. Then I can remove this one out altogether. Make sure we reset manual attachment. Now we do need to update our width. So we know that's 400, so I'm just going to hard code that to 400. I mean, at this point, probably be a good idea to set that to a variable so we can adjust it later, but you know the drill at this point. All right, cool, and it's already working. So now as I take my endpoint and I increase it out, we get more and more copies of the wall that have doors in them, which is actually a little cooler to show off in this case, because you can use those gaps, right? So you can run in and out of each one. So now you've seen a practical approach to using for loops to create procedural elements for your levels. That is going to wrap things up for this video. Thanks a lot.